Hey guys, it's me Alphas again. Welcome back to another interesting session. Today we'll be exploring some programming stuff. It's pretty interesting. Actually, I'm planning to start one new session for C Sharp. It's C Sharp for pen testing. It's a part one, and here we'll be exploring um, how to encrypt and decrypt your shellcode using AES-256. This is not going to be a complete C Sharp beginning session, or it's not beginner friendly one. If you have some familiarity in programming, and it will be easier for you to get understand it. We'll be looking into different ways of encryptions later. I'll be starting with AES 256 shellcode encryption and decryption first. Let me take you to the demo. For the purpose, I will show you our shellcode encryption. This is a project that we'll be using. Uh, I just made different projects for demo purpose. Is one is for encrypt and other one is for decrypt. And there's a normal shell builder, and here we are using technique called thread injection. Um, if you are not familiar with what is thread injection, strongly recommend you to go and check what exactly it is. I can give you a brief about that. It's nothing but we are creating a new thread on the same process that the exe is running. On the new thread, we will be injecting our shell code, so that shell code will be executed on a new thread on the same process. The new that new thread's shell code will give back our metadata shell to our server, CNC server. So normally, for thread injection, we use three Windows APIs. One is virtual alloc, and next one is create thread, and last one is wait for single object. These three are the main Windows APIs that we make use of to create a thread injection manually. And one more thing, this is very well-known technique, and most of the AVs knows this technique, and some AVs will flag you if you use any of these common Windows APIs without even checking what exactly the content that may flag you. So here we will be what we'll be trying is we are going to use these three APIs, and these three APIs will be helping us to create a new thread on the same process, and the new thread we'll be injecting our shell code. So for the encryption that we are using is AES-256. This is a decryption code. I will show you the encryption thing stuff here. Here, this is a main encryption area that takes place. This AES encryption shell AES encrypt shell code function, after accepting the shell code as byte array and key and initialization vector as parameters, this starts encrypting um, the byte array that we pass as a parameter to this one, and mainly the it's 256, and the block size is 128. And I hope you have a basic understanding of how AES works. If it's not familiar for you, just please do a search. It's very easy to understand. And regarding these stuffs like what a block size is and the padding and the mode of AES encryption, uh, that's beyond the scope of this tutorial, so I'm just keeping it for some other exclusive tutorial. For the sake of this one, we are just giving an idea. We are just using AES-256 encryption algorithm for encrypting our shell codes. And this is the main function that we are calling for encrypting our shell code. And the actual encryption of the bytes happens on here. It creates crypto stream and just encrypts based on the key and initialization vector we passed into this one. So after that, you just understand what happens after the encryption is it just gives us string of gives us an encrypted byte array. So for the sake of understanding the byte array, that we create a string builder class and just create an object of the string builder class and printing that in a format of 0x uh, format. Because C sharp shell code, if you are familiar with how Metasploit creates shell codes for C sharp format, that is in 0x format. So we just print out that in a 0x format after encrypting the shell and the byte array. We convert that into hexadecimal format to make use of in the other program for decrypting. So this is the first program we'll be running. And one more thing here, in this demo app, you can either make use of base64 string that will be converted to key and uh, initialization vector, or you can make use of your own key and initialization vector. Um, I'm preferring to use this one because this the creating your own key might be it will be difficult for you to create a random key. So and one more thing, I'll be sharing this code in my GitHub, and if you feel that you really want to mm, make it more convenient, you can make use of this app. This is a simple app. You just click just generate IVN key. It will give you the base 64 initialization vector and key that you can make use of encrypting and decrypting. It's up to you whether how to use that. So here I just already created one key and initialization vector to encrypt. As I said, once we encrypt that, before encrypting we have to supply our byte array here. So we need the actual shellcode to encrypt. So for that, what we have to do is we have to generate our own shellcode. I'm expecting a basic experience in using Metasploit and how to create shellcodes and other stuff. So here I'll be, yeah, I'm going to use this reverse HTTP shellcode. And this MSFNM format is MSFNM, then your hyphen P after that, your which payload you want to use, then the payload options. These are the bad characters that we have to avoid in our shellcode because there's a high chance of breaking shellcodes if we any of these bad characters included in our shellcode. So I'm just asking MSFLM to produce a C# format raw shellcode for me. So this will be, I mean, this lhost is the same IP of your server, whether it can be the same from where you are generating your shellcode, or normally it is a CNC server IP. So this is a command you have to execute. This command will give you the raw shellcode that we can make use of encrypting. So I'm copying this shellcode. I'll be sharing this. I'll be making this shellcode to get access to my development machine. So so that we can check this for encrypting. So let me sudo. I'm just the last is 089 048. Yes, wait, wait. Yeah, it's the same one before. Uh, just copy that to our Apache web server folder. I'm just starting our file service. So this will be just confirming this is IP, and I have given the same IP for the L host. So now we can access this shellcode file inside my development machine. So I can take that and supply that as an input to my encryption AES-256 encryption application. Shell.txt. I'm just taking this and come here on the shell builder. I'm just applying this one in our byte array. And what the application is going to do is it's going to take this byte array and it's going to apply the AES 256 encryption algorithm by using this key and initialization vector. It will give back an encrypted shellcode, and we'll be printing that encrypted shellcode in the same format. So we can make use of that encrypted shellcode and supply to that the decrypted application. That application will decrypt the shellcode at the time of running by creating a new thread and executing that shellcode inside the thread. So here we are going to run our um, encryption application. It's in debug mode. I'm just checking it. Debug x64. One more thing. Our target is x 64-bit OS, so I just exclusively selected 64-bit metadata reverse TCP shellcode, HTTP shellcode, just to ensure that it will work there. Even 32-bit will work on the 64-bit OS, but some of you will come to know more about the difference while you are doing more pen testing or red team activities. So here I'm just showing you how easy it is to make your own uh, custom shellcode and encryptor. Yep, we just applied this one. Now we have to run this app. Just start. I hope it will run. Yeah. So this is shellcode we got the decrypted shellcode, and now this is a decrypt file application, and here I already one shellcode. I'm removing that, and this is a decrypted one. So for the sake of checking this one in runtime, we just printing the same thing on the victim machine. In real time, we don't do this. We will make it more stealthier and real time, and don't expect this will work. Definitely, the antivirus may catch you because of the usage of these well-known Windows APIs. There are alternate ways to bypass AVs. That we will be covering in detail later videos. So here we have just supplied that decrypt encryptor shellcode, and just ensure that you are supplying the key and the initialization vector, that is the same key and IV that you use for encrypting. So I'm just ensuring these two. here. So it's just doing that reverse order. It's just taking this encrypted shellcode and decrypting it using the key and initialization vector, and finally it gives back the original shellcode, the actual shellcode. So what we do with the actual shellcode is we are trying to print that just to ensure that it's the same thing. And after printing it, actually in real time, this printing won't be there. It's just for sake of learning purpose. I just printed it out just to show you. It is the same shellcode after decryption. We are getting the original one. So after decrypting the shellcode, we are just making buffer length enough memory for a shellcode to run using the virtual alloc uh, uh, Windows API. We have to supply enough permissions like the read, write, execute, and we are allocating memory for our shellcode, then copying our shellcode, actual shellcode to the buffer size that we allocated using uh, the virtual alloc. Then we create a new thread and we are passing our allow we are I mean making our memory to get executed using the create thread. Here you just check that you can see that the virtual logs return value is used in the create thread API. So after this the shellcode will execute the decrypted shellcode will execute on the victim machine, and it waits for executing the actual thread. uh, but there's a specialty for this constant. If you check for that, you'll get more details about this one. Just have a Google search for these details. Here I'm just trying to show you how easy to make use of this in C Sharp, because C Sharp, if you have any doubt on the APIs, there's a website called pinvoke.net. This website will give you more in-depth details of almost all, not all, but majority of the Windows API's signature that you can directly use, copy and paste it into your uh, C Sharp application. You don't need to buy heart anything. Just try to understand what exactly the parameter means and what's the corresponding data type in C Sharp that matches with the type that mentions here. You can make use of this site to uh, check your if you have any doubt on the signature of the Windows APIs. I use that one and I just copied the signature and I'm using it here. So here we will be, yeah, I'm just closing this encrypted one. Now I'm going to build our decrypted exe. So I'm just going to configuration manager and ensuring that I'm going to make in a release mode, and I'm going to build the decrypted exe using this one. I'm closing it. I'm just building that decrypted exe. So I'm rebuilding it. So this will create a 64-bit binary for me under release folder. We Let me check that. Oh, no, no. Oh no, I didn't create. It's an old one. Oh no, I didn't go to the release. It's 12:15 here. Yep, this is the one that we are going to make use to supply to the victim machine. So I'm going to copy this one to sharing with my VM share folder, and this file is copied there. This folder is shared with my virtual machine, so I can get access to this folder inside my virtual machine. So here is my victim machine. So before starting the victim, before running the application inside the victim machine, you have to be ready with your server. So for that, I'm just starting my Metasploit with a pre-configured RC file. I'll show you is an easy format, so there's nothing special here. I'm just pre-configured everything. This is the same payload that we used to create, the shellcode. So I'm going to run Metasploit with the same resource file. So now it's waiting for the connection. It's running behind the scene on the same. You have to ensure that your payload IP and port are same. I use the same port for creating my shellcode. Otherwise, it will never come back to your port. So just to ensure that you are setting up the same port. And here, let me copy my shared folder. Yeah, it's decrypt.exe. Here one file is copied. If everything goes fine, this will automatically decrypt the shellcode, and you will be getting the session in our Metasploit machine. Yeah, I'm just checking it. I mean, it's a sake of learning purpose. I just printed that. The last line is 08789. If it's correct, yeah, this is a actual actual original shellcode, and we successfully decrypted that. So this is a decrypted output of this exe. So just to go back to, yeah, we got the session. Yes, sessions. Yeah, we have an active session. Just interact with the session. Just ensure that it's working. Yeah, cool, it works. So again, go back to our code. What we did, uh, we did an AES-256 encryption and decryption. First, what we did, we did take the raw shellcode from Metasploit. Then we encrypted that raw shellcode using AES-256 using the initialization vector and key that we specified. Then this application gives us the actual encrypted payload. So we took that and placed here inside this encrypted shellcode byte array. So here what is happening at the runtime is it is decrypting is the same. I mean, it's doing the reverse process of the encryption. We are supplying the same key and initialization vector. It's decrypting it and gives us back the actual original shellcode. Then we uh, create a buffer for our shellcode with execution permission. Then we copy our shellcode, decrypt the shellcode to the buffer memory buffer that we created, and finally we execute that shellcode using create thread. Then that's a result that we saw just now on the victim machine. Once that is get executed on that machine, you will get a reversal back to your CNC server. So that's all I planned for this video. I'm sure it will be pretty clumsy for someone who never did programming, or if you are familiar with at least one of any kind of programming languages, you'll be getting an idea of what happened here. Uh, the best thing, the core thing that you have to understand is all the encryption algorithms are working on bytes, on byte arrays. So whatever stuff we are going to give a string or whatever it is, it will be behind the scene, it will be converting to byte arrays, and the actual encryption is happening on the byte sequences. So this is the first one I'm planning. The next video will be covering more on the XOR and RC4 encryption algorithms and how effective it is bypassing AVs. Unfortunately, this direct stuff will be caught by Defender. Um, there are ways of bypassing it. In fact, next the another way that you can try is instead of directly creating mm, directly taking this shellcode into your mm, application, you can remotely download it from somewhere and trying to decrypt and execute using the same method. And there are alternate Windows APIs that you can try. Instead of create thread, you can find something like create fiber Windows API, and instead of virtual alloc, there are some alternatives like virtual alloc X. Uh, there are there are different other APIs that does the same stuff, but may not be straightforward like the create thread and virtual alloc, but that may not be on the list of areas or AVs that will help you to bypass. So yeah, definitely I'll be sharing that coding experience with you. One more thing I can share with you is my progress in AV Buster's Windows version. I was pretty busy with this application, in fact, and all the stuff that I showed you now manually, I have added into the AV Buster, so you can done all these stuff just by clicking some buttons. I'll show you a simple demo. Yeah, this is a new version of AV Buster, AV Buster C# version. So what I have done here is I'll be showing an entire demo for after completing the entire application. So here, there's the same thing. You can just give your shellcode encrypted, original plain shellcode here, and click on generate key and IV, and then click the encrypt. It will give the encrypted shellcode. You can copy these details, keep these details with you, and here the same application. AVBuster has another option for shellcode injection. Here you can paste your encrypted shellcode and select your uh, type of injection stuff. Um, just one more thing I had to add here is the decryption keys and IVs I have to supply here. Then when you build, when you click on the build button, it will entirely automate the process of uh, creating this binary stuff that we did manually here. I'll be soon releasing this to my GitHub. Just stay tuned for that. And that's all for this video. This is a short beginning for the C# for pentesters. I'll be sharing more on other videos. So stay tuned. Till that, it's a bye from Alphas.